Go!
My project is will changing the angle of a turbine blade to increase the efficiency. And here are some of the kinds of turbines I'm using. Well, I mean, they're all, so they're called Savonius turbines. They're not the standard kind that you see here, the kind that they're more used residentially. But they are a vertical axis wind turbine, meaning that the blades are parallel to the ground instead of perpendicular. It uses drag to generate energy, the force of drag. And some say, what I'm trying to test is if twisting the blades will increase the efficiency, because some say it does, but some say it just makes the machine less stable. So my purpose is to find if the standard Savonius turbine will work better than a Savonius turbine with the angles twisted by 20 degrees. My hypothesis is yes, it will, because the blades are larger and it can scoop up more drag that'll help propel the turbine. My procedure is first to make two Savonius turbines, one with a 20-degree slant on the blade, and then you build the frame for them like this with my frame made of wood. And so then I got a box fan a meter away, and I used a meter stick to measure a box fan. I put it a meter away, and I turned it on, and I'll come back to this in just a bit. I counted the revolutions per minute. I recorded all of my data, and then I repeated on both medium and high speeds. Then I switched the turbine for the one with 20-degree slant, and I repeated my steps. And then I recorded all the data. Now, I did this by using frame-by-frame analysis. I videotaped it, and then I looked at it frame by frame. So here's an example of a video.
Is it on YouTube or something?
No, I just put it in, and when I clicked it before, well, it would.
Why don't you right click on it? See what it does? Right click on it.
I got it on quick. But anyway, I looked at it, but then I chopped it into frames. So, for example, you can see this is what a revolution looks like. I put a dot on it, and I put it into a frame so you can see it going around. It starts there and it ends at the same place, so that I count that as one revolution. My results were that here is a graph of the averages for my results. It's kind of interesting because as you see here, the Savonius 2 on the medium speed and the Savonius 2 on the high speed kind of work the same. So I concluded that there's a maximum speed that they can run at. But and the other thing is the Savonius 2 on the low speed works better than the standard Savonius. But then on the medium and high speed, the standard one worked better than with the one with the angle slanted at 20 degrees. So that proves that I partially accept my hypothesis. It did work better on the medium and high speeds, but the one with the slant worked better on low speeds. And yeah, I also concluded that there seems to be a maximum speed which they can operate in successfully. And also, I'm also in the future, if I'm going to do another experiment like this, I'm also interested in how other residential, more residentially used turbines work, such as Darius, which uses airfoils instead of scoops to operate. So I kind of want to look into that more, and I think I'm done.